This is the 4.1 through 4.3 test review. For problem number 3, it says to find the critical numbers for each of the following functions and the absolute minimum and maximum. So for letter A, our first function, in order to find our critical numbers, we need to first find our first derivative. So f prime of x is equal to 3x squared minus 12. And then we want to set that equal to 0 and solve for x in order to determine the critical values of the function. So 0 is equal to 3x squared minus 12. I can certainly factor out a GCF of 3 here. Then I will have x squared minus 4. And then I can factor x squared minus 4 into x plus 2 and x minus 2. So based on that, that tells me that the critical values of my function, the values that would make the first derivative equal 0, are going to be x equals negative 2 and x equals positive 2. The interval that I have been asked to look at is the interval from negative 3 to positive 5. So now the last part of the problem just requires me to evaluate this function at the endpoints of the interval and at the two critical values. So again, this method is referred to as the closed interval method. So I need to check f of negative 3, that is an endpoint, f of negative 2, f of positive 2, and f of positive 5. Okay, and again, positive 5 is my other endpoint. I'm marking those with asterisks. So then I'm just plugging these values into f of x. So negative 3 cubed is going to be negative 27. Negative 12 times negative 3 is going to be positive 36. And then plus 1, you add those together and you get 10. When we plug in negative 2 cubed is negative 8. Negative 12 times negative 2 is going to be positive 24, and then we have the plus 1, so this gives us a value of 17. F of positive 2 cubed minus 12 times 2 plus 1, this gives us a value of negative 15. And then finally, f of 5 cubed minus 12 times 5 plus 1 gives us a value of 66. So now based on these results, it's easy for us to see that our absolute minimum is going to occur at 2, and that is negative 15. So this right here is our absolute min. And our absolute maximum occurs at 5, one of our endpoints. This is our absolute max. Okay, we are going to do the exact same thing with letter B, except our function is obviously different, and this one involves some trig. But we start the same way. We start by finding the first derivative of our function. So f prime of x is going to be equal to, the derivative of x is 1. And then my coefficient negative 2 is going to come along for the ride. The derivative of cosine is negative sine x. And then I can simplify this. F prime of x is equal to 1 plus 2 sine x. And then I'm going to set this equal to 0. And if I want to know what x values make this 0, I'm going to do a little bit of algebra here. So I'm just going to subtract 1 from both sides. Negative 1 is equal to 2 times sine x. And then I'm going to divide by 2. So then I get sine x is equal to negative 1/2. So of course, then the question is, well, where does this happen on the unit circle? So if we think about our unit circle, sketch a little picture here. Here's our unit circle. I know that the sine value is the y value of any given ordered pair. And so if I'm looking at where this is happening, keeping in mind that my interval is from negative pi to pi. So basically, one trip around the unit circle, but starting here at negative pi, and then going all the way around to positive pi, right? So that's the interval that I'm looking at. So where on that interval is the y value of any given ordered pair negative 1/2? Well, keep in mind, my y values are negative in quadrants 3 and 4. And the y value is 1/2 at the pi over 6 locations on the unit circle. So this is going to occur here and here, right? At those pi over 6 locations. So when I think about this on my unit circle, my critical values here are going to be, this would be considered negative 5 pi over 6, because again, I'm starting at negative pi and I'm going in the forward direction, right? And then this right here would be negative pi over 6. And then I don't have any in the first or the second quadrant. So those are my two critical values for this function. So now I'm going to do the same thing. I know my critical values, right? And I know my interval from negative pi to pi. So now I'm going to do f of negative pi, f of negative 5 pi over 6, f of negative pi over 6, and f of pi. And I am plugging those into my f of x function. So when I plug in negative pi, I end up with negative pi, that's just plugging it in for x, right? Minus 2 times, and then the cosine of negative pi. Okay, well, that ordered pair right here, doesn't matter if it's negative or positive pi, it's the same ordered pair, right? That ordered pair is negative 1, 0. So the cosine value there is going to be negative 1. So then I have negative 2 times negative 1, which makes a positive 2. So I end up with 2 minus pi for this value right here, which if we simplified that would be negative 1.142. Oops. Negative 1.142. Okay, so f of negative 5 pi over 6. Well, I'm going to have negative 5 pi over 6, that's the x, minus 2 times the cosine at 5 pi over 6. Again, doesn't matter if it's negative 5 pi over 6 or if it's 7 pi over 6, it's the same terminal point. So that point is in the third quadrant. The ordered pair is going to be negative, negative, and the cosine is going to be negative square root of 3 over 2. So here I end up with negative 5 pi over 6. Negative times negative is going to make positive. The 2's are going to cancel. So basically I end up with negative 5 pi over 6 plus the square root of 3. And then you grab your calculator, and that is negative 0.886. All right. Now I do f of negative pi over 6. So again, I'm going to have negative pi over 6 minus 2 times, and the cosine of negative pi over 6 is going to be positive square root of 3 over 2. So the 2's cancel, but the negative stays. So basically I have negative pi over 6 minus the square root of 3. When I do the math on that, I get negative 2.256. And then my last one, f of pi, is going to give me pi minus 2 times, and then again, the cosine of pi is negative 1. Negative 2 times negative 1 is positive 2, so I end up with pi plus 2, which gives me a value of 5.142. Okay, so looking at my options here to determine my absolutes, looks like my absolute minimum is going to be at negative pi over 6, right? This one right here. Negative 2.256 was my lowest value, so this one represents my absolute min. And my absolute maximum is going to be at f of pi. So this right here is my absolute maximum.